Hello, welcome to another class. We are going to look at the errors in division, and just as been doing the others, we're going to look at some examples for them to see how it can be tested in this area. Now, the first example here we're going to look at is you have the 8.6 divided by 3.4. And then you are required to get the absolute error in the quotient, and also you get the relative error in the quotient. So the first case we are going to do is to have our 8.6 and 3.4. We get their limit, and for the 8.6, of course, the least value here is 0.1. And now the absolute error for that will be a half of 0.1, we get 0.05. So this is plus or minus 0.05. And the same case happened to 3.4. The least measure here is 0.1. Then the absolute error is half of that, we get 0.05. So it is plus or minus 0.05. Now meaning that our 8.6 is going to be either the upper limit, you add 0.05, get 8.65, and then the lower limit is subtract 0.05, you get 8.55. For the 3.4, the upper limit is going to be 3.4 plus 0.05, you get 3.45, and then the lower limit is going to be 3.4 minus 0.05, you get 3.35. So that is our limits for the values given. We want to get the absolute error in the quotient, and the first thing here we are going to get can start with the actual value, or the actual value when we do the division, and this is going to be given by now the 8.6. we divide by 3.4, and this is going to be 2.5294. 2.5294. So when you divide 8.6 by 3.4, then you can get the maximum value. This one is going to be given by now, just like we did for the subtraction. The maximum value when you're doing the division here is going to be given by the upper limit. We divide by the lower limit. So upper limit of the first number, that is going to have 8.65. We divide by the lower limit of the second number, and 3.35. And when you divide these two, 8.65 divided by 3.35, you get 2.5821. 2.5821. Then we want to get the minimum value, and this is going to be given now by the lower limit of the first number. We divide by the upper limit of the second number. So the lower limit you're going to have now the 8.55. We divide by the upper limit of the second number, which is going to be 3.45. When we divide these two, we are going to get the value as 2.4783. So that is the minimum value of that measure. Now we want to get the absolute error. Absolute error, you can get it just like we did for the multiplication as the maximum value, subtract the actual, to bracket we add the actual minus the minimum value all over 2, and and this is going to be given as now the maximum value here. We have 2.5821 minus the actual, which is 2.5294. We add the actual, that is 2.594, subtract the minimum value at 2.4783. All of this one divided by 2, and that is going to be 0.0527. We add 0.0511 divided by 2. Here. Then this is going to give us 0.0519. So that is the absolute error when we do the division in that format. Alternatively, just like we had for the multiplication, the absolute error can also be given by the half of the maximum value minus minimum value, and this is going to be a half of the maximum value. We have it as 2.5821 minus the actual value, minus the minimum value, which is 2.4783, and this is going to be a half of the 2.5821 minus 2.4783 is 0.1038, and this one would correspond to what we have there, 0.0519. So that's how you can be able to get the absolute error, either in that method or the second method. Then we look at the second part of the question, which is now getting the relative error. And the relative error, of course, is going to be given by the absolute error divided by the actual value. And then the absolute error, you have it here, 0.0519. We divide by the actual value, we have as 2.5294. So when we divide the 2, we're going to get the absolute error, and that value is the same as 0.0205. So that is the relative error. Alternatively, for the relative error, can get it as just like we had in the multiplication. We get the absolute error of each value, we divide by the value to get the relative error for each case. So for the 8.6, its relative error is 0.05 divided by that number. So 0.05 divided by 8.6, we add the relative error of the second number, that is now 0.05 over 3.4. And when you add these two, they should give you the same value as we have there for the relative error as 0.02052. So that's how you can be able to get the relative error and the absolute error in the quotient. So let's look at our example 2. And the question says that given that measurement P is equals to 12.5 centimeters and Q 5.2 centimeters and R 2.5 centimeter, find in 4 significant figures, the percentage error in P divided by QR. So the first case, we get the limits for our values of our measures. P is 12.5, and of course the absolute error here is to be 0.05, meaning upper limit is 12.55, and then the lower limit should be 12.45. Our Q is given as 5.0 centimeters, and then the absolute error here should be 0.05. So the upper limit should be 5.05, and then the lower limit should be 4.95. Then we have R, which is given as 2.5 centimeters. So the absolute error here should be 0.05. Then the upper limit will be 2.55. Then the lower limit will be 2.45. So from there, we want to get the percentage error. We are going to start by getting the actual value. Can start in either. So the actual value of this P over QR will be, our P is 12.5 divided by QR. Q is 5 times R, 2.5, and then multiply the when we divide 12.5 by 5 times 2.5, we are going to have as 1. Then we can get the other value. We can go in the next one as the maximum value. So the maximum value here, we are going to have, because we are dividing, the upper limit should be, so the P over QR, we want to get the maximum value. So our our numerator should be at maximum, or the upper limit, and then minimum, our denominator should be at the minimum, or at the lowest part of it. So P being maximum, or the upper limit, should be 12.55. Then you divide by the QR. QR is multiplication. The minimum multiplication, we are going to multiply by 4.95. We multiply by the R minimum, 2.45. So that is our maximum value. So 12.55 divided by 4.95 times 2.55, you get as 1.0348. 1.0348. Then we want to get now the minimum value of P over QR. So the minimum value here, we want to have the numerator should be at minimum, or the lower limit, and then the denominator should be at maximum, or the upper limit in that case. And for P, we want to get the lower limit, which is 0.45, and then we divide by QR being maximum. We are multiplying the QR, so we multiply the upper limit, 5.05, multiplied by then R being upper limit 2.55. And that one we are going to get 0.96668. So that is our maximum value and the minimum value. Then we want to get the absolute error in then P over QR, and this one can get us as a half of the maximum minus minimum, and this is going to be a half of the maximum here we have as 1.0348. 1.0348. We subtract the minimum value 0.9668, and then this is going to be half of 0.068, which is going to be 0.034. So that is our absolute error. Then we are interested with getting the percentage error, and of course the percentage error is going to be given as the relative error multiplied by 100%, and relative error is given as the absolute error, so 0.034 is divided by the actual measure, which is 1. That is what you got here, and then multiplied by 100%. So when you get to 100, you go to step forward 1, 2, you get 3.4%. But our question says that we give our answer to 4 significant figures, so we're going to write this one 3.400%. So that is the percentage error in that case. Our example 3 says that given that A is greater than or equals to 2 and less than equals to 4, and B is greater than or equal to 0.1 and less than or equal to 0.2, find the minimum value of AB divided by A minus B. So it's a very interesting question here, and can start by having our A, and we told that the maximum value of A is 4, and then the smallest value of A is 2. Then B, the same case, the maximum value of A is 0.2, and then the smallest part of it is 0.1. So those are the values of A and B. The upper limit of A is 4, and the lower limit of A is 2. The upper limit of B is 0.2, and the lower limit of the same is 0.1. We want to get the minimum value of AB. We divide by A minus B. So the first case here, for us to get the minimum value of AB divided by A minus B in our numerator, to get the minimum value, we have to have it as the minimum, and then for the denominator, for us to get the minimum value, should be at a maximum. So let's get the minimum of AB. Minimum of AB would be the lower limit times lower limit, because we're multiplying. So this is going to be the lower times lower limit, which is going to be 2 times 0.1, you get as 0.2. So that is the numerator. Then the denominator, we want to get the maximum. This is denominator. This is numerator. Maximum of A minus B, and maximum in the subtraction, because we are subtracting A and B to get the maximum. Then we are going to have the upper limit minus the lower limit, and that one is going to be the upper limit of A, which is 4. We subtract the lower limit of B, which is 0.1, and then 4 minus 0.1, we get 3.9. So our minimum value of AB divided by A minus B will be AB divided by A minus B the b, the numerator is 0.2 divided by the denominator 3.9, the same as 2 over 39, or if you can give it into decimal form, it's going to be 0.05128. Now let's look at our last example. We have given that y is greater than or equals to 8 and less than or equal to 12, and x is greater than or equals to 1 and less than or equals to 6. Find the maximum possible values of y plus x divided by y minus x. So, very nice question. Let's have our limits for x and y. Y, we've been told that is greater than or equals to 8 and less than or equals to 12. So the maximum value for y is 12, and then the minimum is 8. For x, the upper limit is 6, and then the lower limit is 1. So we want to get the maximum value in y plus x over y minus x. So for us to get the maximum value in division, the numerator should be maximum, and then the denominator should be minimum. So our numerator, maximum, in addition, we get the upper limit plus the upper limit. That is going to be upper limit plus upper limit. That is going to be 12 for y plus 6. That is going to be 18. Then that is the numerator. Then denominator, we want to have the minimum value in denominator, minimum value. So the minimum value in subtraction, we get the lower limit minus the upper limit of the second number. So the lower limit of y is 8, and then the upper limit of x is 6, and that is going to be 8 minus 6 is 2. And then, so our maximum value for y plus x divided by y minus x will be the numerator at maximum, which is 18, and then denominator as minimum, which is 2, and then 18 divided by 2 is going to be 9. So that is the maximum value.